So we have just practiced a ton of different strategies, and of course there will be more as we come into more and more complicated situations. But I wanted to take a moment to talk about an application of derivatives and how we use it often. So this is rate of change, or we're finding the rate of change of one variable with respect to another. And most often you'll see this with the position function. So if you've taken physics, you've seen the position function. If you've taken MA 102, which you should have to be in this class, you've seen the position function, but we didn't use derivatives with that. So what we're going to look at is the position function, where g is the gravitational constant, v sub 0 is the initial velocity, s sub 0 is the initial height or initial position. So if we have, and again this is the long way, and then we'll talk about easier ways. If a ball is dropped from a height of 100 feet, so this to me says that's my initial position, s sub 0. Its height s at time t is given by the position function. Again, g, we're using negative 32 feet per second, is this. Because essentially what I did is I took 1/2 times 32. Sometimes we put the negative on the 1/2 because it's negative 32 feet per second. You get the idea. The velocity was 0 t, and then the starting height was 100. So that's where that came from. To find the average rate of change over an interval, again, we're going to find the slope of the line created using the beginning and ending times of our two values. So time, comma, position. So again, this is the long way. We're not going to really do it this way much, so just make sure this math should be stuff you're familiar with. So if I'm looking at the interval from 1 to 2, essentially I would just find at 1, what's the height? At 2, what's the height? So really now I have the points 1, 84 and 2, 36, and I'm finding the slope. So the average rate of change is negative 48 feet per second. And again, why is that? Does that make sense? Because our ball is falling, so it would make sense because the ball is being dropped that the velocity would be negative because it's coming towards the ground. So obviously we don't want to use our slope formula for this. We want to be able to use our calculus techniques that we have been developing. So essentially what we're saying is we can find the slope of a secant line over smaller and smaller intervals, which is code for, hey, if this is the slope of my line, I can find the limit as delta t approaches 0, delta t here just being the change in time instead of delta x, which is really this, it's still our x value. So we're saying if we want to find the velocity, take the derivative of our position function. So we have our position function s of t, and then if I take s prime of t, that's going to give me my velocity function. And then we'll talk about what happens when we take a second derivative in a little bit. But essentially this gives us the velocity function. Keep in mind that if we're talking about speed, so be sure to understand if they're asking for speed or velocity, speed can't be negative. Velocity can be, and velocity can be negative because it tells us the object is moving towards the ground or up and away from the ground. So in our last example, we had a velocity that was negative 48, I believe, which means it's moving at a positive speed of 48, whatever it was, toward the ground, because the negative told us it was toward the ground. So again, let's put it all together. We have the position of a free-falling object using the position function, which is here. Know it, learn it, love it. Again, we know s sub 0 is the initial height or position, v sub 0 initial velocity, and g is the acceleration due to gravity, which we're always going to be using 32 feet per second. If we're talking about feet, 9.8 meters per second if we're talking about meters. So we're going to look at this question together, and we're going to do all of the parts. Notice I've given you some information, and then I've asked you two questions that I want you to answer. So let's read the question together and point out things that are important, and then on the next couple of slides we'll work through all the different parts of this question. First of all, it says at time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. So 32 feet above the water tells me the initial position of my diver, s sub 0. The initial velocity of the diver is 16 feet per second, so that is v sub 0. And because obviously all of my values are given to me in feet, or feet per second, my g is going to be 32 feet per second per second. So those are going to be the values that I use in my position function. So we're going to use that information along with these questions to on the next couple of pages. So first one is we want to find out when the diver hits the water, but the very first thing I have to do is I have to find the position function. So I'm using the information that I came up with before. Remember, we said g was 32 feet per second, so I took negative 1/2 times that to get negative 16. The initial velocity was 16, so it's plus 16t, 32 feet above the water, so plus 32. So I have to start with that. Now what I want to know is when will the diver hit the water? So you have to ask yourself, do I need to find the derivative to determine this? Well, the derivative of the position function is velocity. Are they asking about velocity? Not on this question. This question says, when does the diver hit the water? So this is just algebra. The diver hits the water at position 0. So let's set my position function equal to 0 and solve. And again, I've chosen to use factorization. You can also use the quadratic formula. This is stuff that should be easy to you by now. So I find two values that one of them only makes sense. Only one makes sense. So again, thinking about my picture, I had a guy who was already starting at 100 feet. And then the path was a parabola. So does it make sense mathematically that there would be a negative solution? Sure it does. Mathematically, it's a parabola. It's okay that it touches one time on the negative side and one time on the positive side. But in real life, they're asking, when does the diver hit the water? Well, he doesn't hit at -1. He was never there. So in real life, the diver hits the water at 2 seconds. The second question asks us to then find the diver's velocity at impact. So it's important that we found this answer first, because this answer tells us that we are in fact going to find it at time 2 seconds. To find the velocity, remember I have to use the position function, which I came up with previously. And because I'm finding velocity, I'm finding the derivative of the position function. So s prime of t is the same as v of t, which is the velocity with respect to time. So using that power rule, 2 times negative 16 is negative 32, t to the first. 16t to the first would be 16t to the 0, which is just 16. The derivative of 32 is 0. So here's my velocity function, negative 32t plus 16. Now I need to find that at 2 seconds. So now I'm just finding v of 2, which turns into negative 48 feet per second. So our diver hits the water after 2 seconds and is moving at a velocity of negative 48 feet per second. There is a great in-class practice worksheet in the practice section of your OneNote notebook. Remember, the practice section is in the collaboration space. It's not graded, but I encourage you to collaborate with your classmates. Some people, again, like to copy the page over to their own notebook so they can work on it without any help, and then pop over to the collaboration space and talk to their classmates about it after that. But remember, math is hard, and I encourage you to work with your classmates, so don't just try to do this all on your own.